All right, so here's an identity. It's up to you guys. Which side would you like to start on?
The left side.
Kyle says left. You guys want to go with Kyle?
Yeah.
There's 2 fractions over there. That might be something we can do something with. All right, let's start on the left. Cotangent theta, 1 minus tangent, plus tangent, 1 minus cotangent. I think there's probably a whole bunch of ways we can do this particular problem. So, any ideas?
Times the top and the bottom by 1 negative tan on both sides. Then we'll cancel. Yeah.
What's Kyle talking about?
Then
I think he's going for a common denominator. Should we try that?
do the same thing with the code.
So he's saying this one needs 1 minus tangent, that part, and this one would need 1 minus cotangent. Let's see if that works. And sometimes, by the way, until you're a master of these, and even then, you're going to try something and it's not going to work. You got to be willing to back up and try something else, okay? This is very much a process like that. It's like a game. So let's see. I'll use red. I like this idea very much. Let's see if it works. So we'll go that one there. That's a clever one. And we'll go with this clever one here. All right, so let's expand those out and see what we get. On top, on the bottom, the common denominator is 1 minus cotangent, 1 minus tangent, right? Okay, so on top over here we get distributing. Yep, cotangent there, cotangent squared here. And we have a tangent there, tangent squared as well. Any of that stuff cancel, guys? Not quite, right? I really like Kyle's first choice, though, and whoever else was thinking that. It's a very good first choice. That works a lot of the time in identity land, common denominator. That seems pretty intense. Let's see, what else could we do with this? I have an idea, but I'm not going to say yet. Jackson?
Cotangent, 1 over tangent.
Ah, very nice choice. I liked it. Jackson's choice. He says cotangent's really just 1 over tangent. And then maybe we can do something with those fractions. Let's try that. You could also at this point change tangent and cotangent into their other versions. What's their other versions?
Sine over cosine.
Sine over cosine for tangent,
Cosine.
and cosine over sine for cotangent. I think either thing might work. I like your choice though, because there's no sines and cosines in the answer, is there? So let's try that one first. So let's see. So then we could say this is 1 over tangent, right? Right there. Minus 1 over tangent squared. These ones are already tangent. I'm afraid I might not be leaving enough space. Getting a little scared. And then down there we can do it too, right? So we've got 1 minus 1 over tangent times 1 minus tangent. Okay. Still pretty ugly. Let's see. I don't think anything can cancel yet. You could do this lots of different ways. I think you could use a nice clever one, which would really simplify things, though. I'm not sure if it's going to work. I haven't done this problem in advance. You could make a big common denominator on the top with all 4 terms. And then you could make a common denominator inside there with those 2 terms. And then I think you'll start to be able to flip some stuff, do some reciprocal action. Or you could say, you know, the biggest thing I have on any of the bottoms, what's the biggest ordered term that you have on any bottom, any denominator? Tangent squared. So if I just multiply the top by a tangent squared, make it a clever one so it's legal, do the same thing on the bottom, and distribute that through. Let's see if we can get some stuff to cancel, shall we? So I'm guessing you guys might be more comfortable if I had just made one big common denominator up here, same way we did that one, and made one little one here. But this is also something you can try. So if I distribute that red tangent here, what's going to happen?
1 plus tan.
One of them cancels and you get a tangent on top. If I distribute red tangent to this term, what's going to happen? It cancels to just minus 1. If I distribute it here, I'm going to get tangent cubed and tangent to the 4th. Now let's do it on the bottom. Now since this is a product, you only want to distribute it to one thing in the product. If you distribute it twice, it'll be overdoing it, and that's too many. If you're unsure about that, it might be better to just resolve this product first. So you know what? I'm going to resolve the product first, like I said at the beginning, to make it nice and clear for you guys. So I'm just going to leave this other red tangent squared out, and I'm going to make a common denominator here. What's this one missing? It's missing the tangent. So let's see. So that guy now has a common denominator of tangent. Tangent minus 1 right there. Now I think it's a little easier to see that this is going to cancel one of those tangents. You guys see it? So we're going to have a tangent cancel this guy off with one of these. Okay, so now let's see what we have left. This is looking a little gnarly to me. I'm not sure. We might have to try something else like the sine or cosine method. So let's see. What do we have left? On the bottom, we're going to have this is like almost difference of squares, but not quite. I think I'm just going to have to distribute it. I'm looking ahead and trying to see where we're going to get. I'm not optimistic. That 1 is screwing stuff up. So you can see even I get stuck on some of these if they get hard enough. So don't be afraid to get stuck. You just got to keep trying stuff. So I'm going to distribute and see what happens. Tangent minus tangent squared. And then this is minus 1. And this is plus tangent. And I've got this all times that red tangent there. My top stuff is still chilling. Let's see. It's looking very similar. You guys see some stuff that's really similar? So minus 1. So tangent. These guys are just too big. That's the main problem here.
Can we just start again, trying?
Yeah, we might have to. I mean, I'm getting stuck, so. Yeah, we might want to just go for cosines and sines. I don't know. I'm getting a little stuck right here, so I'm
Can
gonna.
you not just pull some of it out?
Yeah, we can. That's what I'm thinking too, Michael. Is you could like pull a tangent out of just some of the terms, and it might be able to cancel. But I don't know. It's just not looking very productive. I think we're missing something that's key. So that's going to happen to you. So I'm actually not. I'm not upset that we made a mistake. It's not like we made a mistake that I see. I mean, it's just you get stuck sometimes. You got to try something else. So let's try something else. So I was thinking originally of just at the very beginning going and trying to write this in sines and cosines. Let's try it that way. So let's see. Cosine, cotangent is cosine over sine. Sine over cosine. And same kind of thing here. Same kind of thing here. Okay? So, I'm going to make a common denominator out of both of these denominators. So you guys tell me. What's this missing, this 1, if I want to make these into one fraction? What's it missing? It's missing the cosine. What's this missing if I want to combine these guys? It's missing the sine. Couple clever ones. Let's see if that helps us. I think it's going to. So what we were doing on that other way, I mean, it would have eventually worked too. It just depends on how clever we need to be to finish. And sometimes you just get to a point where it's a dead end and you just got to try something else. Then over here. Gonna have that. Okay, now we have two monster fractions. What can you do with monster fractions like that where there's just one fraction over another?
Copy, dot, flip.
Copy dot flip, exactly. Let's copy dot flip and see if some stuff cancels. So copying, dotting, and flipping. I'm going to put these in parentheses. Same kind of thing here. So you said some stuff cancels? I don't see it canceling, but what are you seeing, Kyle?
The cosine.
It's going to be cosine squared, isn't it? Yeah, I think so. Okay, so now we got that. This is cosine squared. You could distribute this if you want. I don't know if I'm going to distribute it. So this one's going to be cosine squared. Got sine, cosine minus sine. This one's going to be sine squared, right? Got cosine, sine minus cosine. Okay, so a second ago we got kind of stuck at this point in this problem. These parts right here are really similar. They're just reversed, so I'm going to factor out a -1 on one of them. So I'm going to pull out a -1 in front, which will eventually come and go right here. So if I pull out a -1 there, this guy's going to become cosine minus sine, like I was wanting all along. So now at least those have the same thing. The common denominator is not complete though, because this one is missing the sine and this one's missing the cosine. So I'm going to fix that with clever ones. So now let's see what we have. Now at least we have a common denominator. The common denominator has a cosine, it has a sine, and it has a quantity cosine minus sine. Let's see what's left on top. Here we've got cosine cubed. Here we've got sine cubed. And at this point, I think this problem kind of leaves the realm of Algebra 2. It depends, I guess, if you have an honors Algebra 2 class or what you're doing. But this is one thing cubed minus another thing cubed. That's very much like difference of squares. You just got to use the difference of cubes factoring formula on it. So that's something you don't end up running into in high school a whole lot, but here and there. So if you remember, or if you haven't seen this before, here's how you factor difference of cubes. If you have a quantity a cubed minus b cubed, that factor is really similar to difference of squares. You go a minus b, and then you might guess this can't just be a because they've got to multiply to a cubed, so this is a squared. This can't just be b because they've got to multiply to b cubed, so it's b squared. And the way this works is plus ab in there. So I'm going to now factor the top using that factoring scheme, whether you've seen it before or not. So I'm going to say the thing being cubed here is cosines. This is cosine minus sine. And I'm going to follow my factoring scheme. Let's have a good weekend. Cosine squared plus cosine sine plus sine squared.
You do Monday.
Okay, the reason that my mind jumped to the difference of cubes factoring formula in the first place was that I saw this on the bottom, and I knew that that was going to cancel out with this part right here, which you can clearly see now that that cancels out. Then what do we have left on top? Well, we have cosine squared plus sine squared. And we have a cosine sine. And on bottom, we also have a cosine sine. And the really nice thing about that is what? Well, cosine squared plus sine squared is one of our most basic identities. It's just 1. That's really just 1 plus cosine sine. So now I think we're getting really close to our goal. So what do we have left? Well, we have 1 over cosine sine. And we have cosine sine over itself, which is really just 1. This guy's going to be secant, cosecant. We have cosecant, secant plus 1. Now let's go back. What were we trying to get to eventually? Okay, so at this point we still don't have what we need. We have secant, cosecant plus 1. I think we were supposed to get something really close to that. Our goal, if you remember, I'm sorry I've erased it off the board to save space. But our goal was to get cotangent plus tangent plus 1. So if secant, cosecant was really the same as tangent plus cotangent, we would finally have met our goal. So this is where I'm going to go again, just like the last example, to the other side of the problem. I'm going to work it down a little bit, and I'm going to see if I can get that part. So really, I just need to establish, I'm going to erase some of this stuff from up above. I really just need to establish that cotangent plus tangent, get rid of this marker, made one for once. Oh, and that's my last black. Let's see, so I need to establish that cotangent plus tangent is equal to secant cosecant. Let's see if we can do that. So I'm going to say cotangent, that's really just cosine over sine. Tangent is really just sine over cosine. Let's see, we can make a common denominator if we multiply by cosine here. And this one's missing a sine. So let's see what we have. We have cosine squared then, plus sine squared. And the common denominator is cosine times sine. Sine squared plus cosine squared is equal to 1. So that's 1 over cosine times sine. And 1 over cosine times sine, you can see it right there. It is secant plus cosecant. So what I'd want to do to finish this problem, because you want to make one uninterrupted chain when you're working with identities, is I'm going to say this is equal to, in fact, you know what, I'm not even going to go to that step. I'm going to, the scratch work that then you're going to put into one complete chain. So then I'm going to say this plus 1 is really equal to, this would be an incredibly clever step going forwards, but backwards we know that's where we want to go next. So we'd go cosine squared plus sine squared over cosine sine plus 1. And then back from that, if you undo your common denominator, that's equal to cosine over sine plus sine over cosine plus 1. And this is our cotangent, and this is our tangent. Whew, man, that was a tough problem. We definitely earned the box. I think this goes beyond the scope of Algebra 2. It's a very difficult identity where you need some more practice. So the worksheet that I gave you shouldn't have any on this level, but there might be a couple where it's going to take several steps. You're going to have to play with both sides a little bit, not working on both sides, and you're going to have a little bit of endurance. And hopefully once you get to the end, like I was telling my class earlier, you're really going to feel a sense of gratification. If you can get one of these tough ones to work out, you're going to do really well. The ones on my final, you'll find, are going to be moderate difficulty at best, and you get to pick 2 out of 3. So that's going to be our first experience with identities. You don't have to be a master of them by any means yet. So I'll see you next time.